Okay, hello again my Math 1 minions. We are working through this applications of quadratics into the real world. This is an example about a sports application where you've got a curved soccer field or a football field, and it's curving like this so that the rain will run off it. I'm exaggerating it. This is in vertex forms. This is actually wicked easy because this is telling you what the coordinates are of that vertex. That highest point is going to be at the point 80, comma 1.5. Okay, so you need just to fit this into your window, and I think you can kind of do that knowing in the real world how many inches high. I think it's in inches. Oh, it's feet. How many feet high a field might crown? Not very much. You can have the base here. This can be like 0, and that can be maybe 3 feet. And then if that's 80 in the middle, you can guess what either end is going to be, okay? But it is going to start at 0, all right? So I'm going to do this one in a little more detail, all right? Again, you have to figure out what kind of form this is given to you. It's not in the form of ax squared plus bx plus c. That's standard form. That's on the other side of this page. This is vertex form. So again, it's wicked easy because in this case, it's going to be still opening up because this is positive. Up above it was negative, so it opened down. But this is a parabola that's going to be going to a lowest point and then going up higher and higher. And we're given that point right there. It is at about 90, 90.2. So over here is going to be about 100. You're told to go between 50 and 150. Okay? That's your domain, all right? And I'll let you figure out the best window. I've already sketched it in, so your view might change a little bit, okay? Just be darn sure you type it in super carefully. So try to save a little bit of time. And I'm going to show you here, all right? Keep it in focus. Turn it on, that's always good. And there's the equation, all right? So just make sure you don't switch a negative sign with a subtraction sign like it's supposed to be. Make sure you don't forget any x's. Don't forget any exponents. There's the 2 up there. Okay. And then, I mean, you could do zoom 6, right? But if you do that, you're going to get nothing often because in the real world it's either too big, too small, too high, too low. You got to go to the window. And here I think it's pretty clear that we're told to go from 50 for a minimum up to 150. That scale can be 0, but you can set it at like 10 or 15 or something. The y minimum, this is a parabola that's going upwards. We know the lowest point is about 50, so I'm going to start at like 40 and then go up to a maximum of say about 90. Let's see if that's alright. And that scale may be about every 10 units. Again, you can just set it equal to 0. And lo and behold, I gotten it right there pretty well in the first go. Okay. But I want to show you how to find that lowest point pretending we did not know what it was because we were not given this equation in vertex form. Alright. So this will help you on the front page. To find that lowest, I could just trace. When in doubt, trace it out. That's a pretty good guess. Right about there. But we can find it exactly by going to second in calc menu. So calculate menu above trace, and notice I want to find the minimum value there. 3 is the option, and I'm asked to find what is the left hand boundary. You just need to make sure you get to the left hand side of any low point or high point. I'm definitely there, and then I need to scroll over to find a point that's definitely to the right of it. As soon as I go up a couple clicks, I'm good. Hit enter. You see these little pinchy things? They show you that somewhere in between there should be the minimum. I'm good to go. They want you to guess. I'm going to guess the vertex, but hey, let's see. There it is, 90.2 and 51.3. Okay? So you can write a little descriptive statement. What is your interpretation of these numbers? I'm thinking that if I'm able to walk in about 90 meters per second, I'm going to burn my minimum number of calories, which will be 51.3. If I walk slower than that, it's not efficient and I burn more. If I go faster, I'm exercising a lot and I'm burning more. And that's what we kind of mean by that. Alright, so you should be able to do these guys This one is not vertex form, so you might have to multiply that out or simply type it in and do the same sort of math. All right, good luck. Oops, I was right there.